Hello, everyone. This is Professor Chen, Mechanical Engineering. Today, I want to give you a 5-minute head up about the Chapter 5. Here, this is for Chapter 5. Here, we're going to learn how to draw a shear diagram, and we call the VX diagram, and bending moment diagram. And we call the MX diagrams here. This basically is one kind of the review from statics you learned before. But quickly, we can put into here. The first one we need to adopt is the sign conventions for these chapters. And the sign convention, let me do this one quickly here. If you have sections, the section facing to the right, that faces to the left, for this portion. So this is a portion of the free body diagram. For this one, if you pick up a cross section that faces to the right, and that belongs to these categories. For this category, we defined the positive for shear and moment is like this. This is a positive shear, and this is a positive moment. And for this category, we define a positive shear and downward and positive moment like this. With these sign conventions, we're going to draw the diagrams here. And let me use one example quickly to demonstrate the concepts here. So if we consider one example here, this is a beam, and for example, it's on the cantilever, on the simply supported. And we make a very simple case. For example, if this beam is under a point loading right at the middle here, and the magnitude equal to F. And here, that is the way we we draw the shear diagram and V, and they put a 0 here. Above this portion in the upper quadrant is positive value, below is negative, and which the sign of which is determined by the sign here. And then we draw the corresponding bending diagrams. And here is moment, and this is 0. And again, the sign depends on the sign convention here. So to make this drawing, let me mark the domain of the problem here. So corresponding, I align the from 0. This is starting from 0 to the left hand and extend to the right hand side here. And the very first step is we have to calculate the reactions at the support here. And here, allow me to use a tail, and here, little tail here to indicate that is induced or calculated reaction. And for this simple case, you can quickly identify, verify the reaction here is both F over 2 here. Okay. So now how to get all the information to follow up the sign convention to draw the curve on here. That is the way to do here. We're starting from the left hand side. You can see this is a cross section that's facing to left. So we pick up this portion for our sign conventions. So that is the transverse loading and half of F and point upward here. So according to sign, that is positive. So we're starting from here. That is positive F divided by 2. And we're going to learn in this chapter two important formula is this dV dx equal to minus omega. Omega here is the distributed loading. And for this example, what is distributed loading if this is a beam, and then if we have loading something like this. So you can visualize this is one kind of the pressure-like loading case. For this case, we don't have. So this equation is simply saying, this is saying is the slope on the Vx diagram equal to 0. So we're starting from this value, In this range, there's no any distributed loading, so slope equal to 0, so that means the curve keep as a flat. Now come to this point loading, this simply is this point loading, put this value downward by the same amount, so that starting from positive half over 2, go downward by f, so that's come to minus f over 2 here. Again, in this portion, there's a no W, no omega, no distributed loading, so we keep flat, come to here, and now come to this value again, that is f over 2 divided minus. So from here you can see, due to the sign conventions, this section is facing to the right. So if we have a negative value corresponding to the sign convention, a negative value point upward, so that means corresponding to what we expect here. Okay, so that is the shear diagram. For the bending diagram, you're going to learn we have the relation is dm dx equal to v. And what this is this one simply saying that is a slope on the mx diagram. Okay, so that means the slope of the m curve equal to value of v. And we're starting from here. For this case, because at both ends there's no bending, so we expect the bending should start and stop at 0 here. And in this portion, the slope of the bending equal to value of this one, the value equal to f over 2. So that means the slope equal to f over 2. And that remains as a straight line. And come to here, this value equal to, you can calculate this value basically is, say, for example, if the whole length is L over 2, the half length is over 2, you can calculate this value here, the m equal to FL over 4 here. That is the value here. In the second portions, again, the slope equal to value of v, which is negative. So now we downward, and then the slope is negative f over 2. Okay, this curve starting from here descends to that much value, then that come to 0. So in this chapter, this is a very simple examples, and you're going to practice quite a few different scenarios of the loading on the beam, which is on the different the type of the support. And again, the two equations plus this sign convention that are going to be used through all the examples here. Thank you.